So next question is, for the reaction 2Cl gas to Cl2 gas, what are the signs of delta H and delta S? Delta H, you know already, we have discussed about delta H. Now what is delta S? Delta S is actually change in entropy. And entropy is actually degree of randomness. Entropy is
Degree of
randomness or measure of randomness.
Yes, sir.
Now, randomness of gas is more than liquid, which in turn more than solid. So in any reaction, if number of gaseous moles are increasing, delta S is increasing.
Yes, sir.
And increase in delta S means positive.
Yes, sir.
And decrease in delta S is negative. Now come to this question. 2Cl gas to Cl2 gas. If we see this question, Cl2 gas to 2Cl gas, what is this? Amount of energy required to break one mole of bonds into gaseous atom. We have already discussed it. Bond enthalpy. And that is always positive. Energy is absorbed. Now here bond is formed actually. In this particular reaction, bond is formed. So formation of bond leads to release of energy. That means for this particular reaction, delta H, for this particular reaction, delta H is negative. Delta H is negative for this particular reaction because it leads to formation of bond. Formation of bond takes place in this reaction. And what about delta S? Yes. In reactant side, how many gaseous moles are there? 2. On product side? 1. That means there is a decrease in gaseous moles. That means decrease in
delta S.
Decrease in randomness. So delta S for this reaction is negative. Delta H as well as delta S both are negative. Okay. So next question is, for the reaction at 298 Kelvin, that is 2A plus B to C, delta H is given to you, delta S is also given to you. Units are same, kilojoule per mole, kilojoule per Kelvin per mole. That is kilojoule. So there is no need to change the units. Now, at what temperature will the reaction become spontaneous, considering delta H and delta S to be constant over the temperature range? Now, delta H and delta S is given, but we have to predict the spontaneity of the reaction. At what temperature reaction become spontaneous? And for that we have new term, that is delta G. Now what is delta G? Delta G is change in Gibbs free energy, and this Gibbs free energy, if it is negative, if delta G is negative, reaction is spontaneous. If delta G is positive, reaction is non-spontaneous. And if delta G is equal to 0, reaction is at
Equilibrium.
So this is the condition for delta G. Delta G is actually the excess energy available for the system to do the useful work. Okay, so delta G, if it is less than 0, reaction is spontaneous. If it is positive, or we can say greater than 0, then it is non-spontaneous. Now we have delta G. It is related to delta H and delta S by the relation delta G is equal to delta H minus
T delta S.
Now for spontaneous reaction, delta G should be negative. We can say less than 0. So that implies delta H minus T delta S should be less than
0.
Or we can say delta H is less than T delta S, or delta H over delta S is less than T.
T.
Or we can write T should be greater than delta H over
Delta S.
delta S. Now T should be greater than delta H is 400 kilojoule per mole
Per mole.
and delta S is
0.2 kilojoule per mole.
0.2 kilojoule. This is kilojoule per mole and this is kilojoule
Per Kelvin.
per Kelvin per
Per
mole.
mole.
Kilojoule cancel. That implies T should be greater than 2000 Kelvin.
Kelvin.
So we can say that if temperature is greater than 2000 Kelvin, then this reaction becomes
Spontaneous.
any temperature above 2000 Kelvin make the reaction
Spontaneous.
spontaneous. Okay, thank you very much for watching this video. Do share, like, comment and subscribe my channel, and do not forget to press bell icon so that you will get notification of my next video. Thank you.